Hi there, my name is Charles. I got assigned to a palletizing project, and I realized that that palletizing project was not just a normal custom automation project. That palletizing project, the client needed to change their palletizing pattern 5 to 7 times a day, which is obviously quite a lot. So that was a big problem for them, and the only solution they had found was to use larger box sizes and to standardize one big box size and start shipping a bunch of air and have their product loose in the boxes. So that was not a solution they wanted to use at all, right? And so with this information, we went on a search to try to help them out and find out what are the things we can do to actually help them. So we tried out all the solutions that were on the market, right? And while trying them out, the conclusions that we found are, well, that first of all, the programming was still very slow. So a lot of interfaces were there. There were nice UIs to program the patterns and to do all the box placement. But the reality is, even though you have a nice UI, you still had to use a USB stick to export it into the USB stick, put it into the robot, try it out, and if that didn't work, you needed to iterate with this. And the entire process was still 15 minutes or so. So that made no sense at all for the client. They needed to change those patterns a lot faster. So the second big problem that they have, well, the long setup time. So what I mean by that is that they actually also needed to, of course, move the palletizer from one production line to another, which they couldn't do because they needed to recalibrate the robot every time. So that was not a good option. And lastly, well, we tried to integrate that solution, right, into whatever makes up a palletizer, because there's not just the software, right? There's a lot of things that goes into a palletizer. But as we tried to integrate the lights, the sensors, the conveyors, and all the parts together, we figured out, well, that system was kind of a black box. There was no way to actually dig in and solve the issues. And for the user, the experience after this is, well, they have a nice interface, the robot is running smoothly, but they have to use the technical components, and they have to mess with the technical components just to get the system working, which made no sense again. So that was not a solution. All right. So essentially, that summer, we made a first prototype with my colleague, and we built that first prototype in a single month. And that same summer, after we shipped that prototype to the client and they really liked it, we found 2 more clients that actually needed the same kind of product that we just built. So after the summer was over, after 3 versions of the same platform, we realized there was a lot of interest. So we actually presented the solution in Pack Expo 3 years ago. And that solution, we call it Paltz. What's really important to understand about this is that we came from a background of custom automation, right? So it was not about just the robot or just the software. It was about providing an actual solution. And to do this, we had a lot of expertise available. So we had an electrical team, a mechanical team, a robotics team, and a software team. And well, it started out by building a base for the robot, because we wanted to put the robot not just on a pedestal, but on a proper base for this. So we built the base, and then we figured out, hey, we actually need custom grippers to be able to properly grab the boxes. So we built a custom gripper. And then we made our electrical panel. And then we actually attached an integrated conveyor that allowed us to not need to always recalibrate the product. And so then we iterated on robot motions, and then we added 3D visuals, and then we iterated on communication protocols, and so on, and so on, and so on, and so on for years now. Now here's the thing. This product is very, very well integrated, and this is what we have today. This is a fully plug-and-play system that you can simply just plug in, start up, and start working with. So the process looks like this. You roll the machine up. It has wheels, so it's really, really easy to set up. Then you set up the safety system. You plug in the compressed air, plug in the unit in the power socket, turn it on, and then you're ready to put your pallets in and measure your boxes. And now, speaking of measuring boxes, we also built a software platform on this so that we could allow the user to be a lot more independent using this system. So we call that platform, that software, StackIt. Now, StackIt is just like this. It's a platform where you can actually see the box, and you can change the box sizes. So you input whatever box you need to do, you measure your boxes, and then you put labels so that we can keep them on the outside while we palletize, right? Then you choose the pallet itself, and we can generate the custom layouts automatically. So we try to find the most stable layout And we proposed essentially like industry-leading stability for the layouts. And you can obviously change that generation with a bunch of options if you need to. And if that's not enough for you, we also have an option to do those patterns manually if you need to. The end result is, well, you end up in the stack page where you can see the final stack and see how you cross the layers and the final look of the pallet, right? And now, for years, we've been iterating and working on this. And it turns out that we still actually developed a lot of things and pushed the technology forward a lot. And last week, we released StackIt 2.0. StackIt 2.0 we use as a way to actually fundamentally fix two of the main issues that we found in this type of palletizing system. So the first one actually has to do with day-to-day operation. Now, what I'm talking about is that, well, the people that use the system don't necessarily need to set up new patterns and new boxes, and they don't need to do all of this. They just need to operate the machine and get through any trouble that might arise, right? And so that led us to build a whole new homepage experience, one where you can actually see the 3D visual of the pallet in real time as it's being built. And of course, we also added a way to change manually the current progress of the pallet. So you can remove boxes. For example, if there's one that's not taped properly, you can take it off and just tell the robot, and we're good to go. Same thing if you have a big error or there's a problem on your line, you want to palletize manually, you can adjust the count very easily. So that made it very, very intuitive for the users. And we also use this as an opportunity to listen a little bit more to the feedback of the clients. And what we found is that, well, they needed to manage a lot of products. So as you saw, we added a new search box for the clients to be able to specify their own products and be able to search them very quickly. And this is just to show one kind of pop-up and the way we actually manage the incident in the palletizing process, so that if there's any issue, they have a step-by-step guide to help. There's a second big issue around this, and it is, how do you know if your pallets can actually be palletized with a product? So with a specific project, right? And you don't, because it's really, really hard, and you don't want, in general, when you're operating a palletizer, you don't want to be messing with errors and having problems with the reach of the robot or ending up having a collision with the robot. So we figured out that, well, the clients actually needed to do one of two things. The first thing is to use very complex, long-running simulations just to check out if the robot could do the moves. The other one is, well, to reach out to more experts, and we did those simulations in the end. And those experts was often the distributors or us, and that didn't really make sense for us to grow with our clients. So we built a feature that we called stack validation. What stack validation is a way to know exactly if your pattern is feasible on the robot or not. So as you can see, there's boxes that appear in red. Those boxes, either the robot doesn't have the reach to do it, or there will be collisions with the stack below or any other type of collisions. So that allowed us to do two things. First of all, the client is now a lot more independent in testing their system, and they know a little bit more about it. But the most important thing, at least in my opinion, is that they are able to develop a lot more confidence in using the system because they know in advance if there's going to be any errors, and we warn them. And so that's more likely that they're able to fully control the system and feel like really at home with the system. All right, now here's the thing. Every time we ship a palletizer, it works very well. We have great feedback, and we've shipped hundreds of those. But in the market, if you look at the market, everything that's first palletized needs to be depalletized at some point, right? And so I've been asked, as an engineer, why can't we just do palletizing, but in reverse? That'd be nice. But sadly, that's not so easy. So the first problem is, well, there's a lot of box variation that can happen. Those can happen because of the shipping, but sometimes it's not palletized properly. And boxes can be damaged, moved around, and that will all lead to errors, right? So that's not really great for the customer. The last thing is that, well, there can be variations in how we place the pallet. And the way we want to place a pallet is usually we put it in a square bracket just to be sure exactly of where it is. But if you've ever driven a forklift, you might have experienced this before. It's actually really hard to put a pallet in a perfect positioning corner. I know I haven't experienced this, but... And so, imagine the feeling of the client when they have this very, very easy to use depalletizer that works most of the time. That doesn't make sense. In the industry, you need reliability. You need sensors, you need a vision system. And this is why we've partnered with +1 Robotics to bring the first depalletizer easy to use on the market. Now, all right, I want to take a few minutes just to talk about some of the challenges that we faced while we were bringing this depalletizer to the first few customers that we had for this. The first one is the vision. So that's no surprise. There's a lot of stuff that needs to be handled on the vision side. The first one being, well, the boxes can vary a lot. So we're talking the types, the format, the graphics on the top, whether there's a shiny tape on top, sometimes there's a label. There's so many variations. And what's worse is that the lighting conditions can change dramatically depending on where it is and if it's moved from one production line to the other. And gladly for us, that was actually the easiest part because we have +1 Robotics to handle this part. And so this, they've been able to output a very precise position data for the robot so that we can pick it up very easily. The second part is, well, I mentioned it before, and we need to be able to move those units from one production line to the other. That's kind of a requirement of some of our clients. So we needed to do two things. First of all, we designed our own camera mounting brackets so that we're able to minimize the number of times we need to redo the calibration with the vision system. And the second thing is, well, we worked with +1 Robotics to actually simplify a lot the calibration process. So we're able to do this in only a few clicks. The third part actually has to do with the performance of the robot, so the general operation. And well, we need fast motions. We need to be able to have a high-performance robot with very small, short cycle times. But luckily, we already have a palletizing system that does all of this. So we have already a motion system that's best in class for the smoothness and how fast it is. So we were able to reuse those modules in terms of software and apply it to the depalletizing system as well. And the other thing is, well, when you use a depalletizing system with vision, you need to also be careful about how we process the vision and how that might interact with the robot. So processing time for vision is still, a few milliseconds or up maybe half a second or something. But you don't want the robot to stop and wait. You need the robot to keep going. So we were able to find a way to properly hide this processing time within the motion of the robot and trigger the camera at just the right time to have the information to keep going with the robot continuously. So that was really cool. But one last feature that was very important to us was the variable multi-pick. So what I mean by that is that we want to be able to pick either 1 or 2 boxes at a time, just because it obviously multiplies the number of boxes you can handle per hour. So that's very, very important for us. And we've had that for a long time in palletizing. It was important for us to also have it in depalletizing. Now, last but not least is the user interactions. Well, as you might have understood already, BeRobox is all about user interactions and having a system that's easy to use. So this was very important for us, and we're still tackling this issue right this moment. But we've optimized already quite a lot of workflows around using this machine so that you're able to essentially put in a pallet, just start the palletizer, and everything is very easy and already handled automatically. And same goes for the errors. So when you introduce a vision system, it can be very complex. And you don't want the user to face that complexity, because if you increase the complexity, you need to work even harder on the ease of use. So that's what we did. We handle the errors automatically as much as possible. But if that's not possible, we have a prompt that can tell the user exactly how to handle the issues. Now, this is the end result. It's a really, really great plug-and-play system. I invite you to check it out at the back. It's really, really cool. It works well. And we have the camera mounting brackets at the top. And yeah, so the next steps for us are quite clear. So what we're going to do is basically, so we have already this prototype fully working. It's not even a prototype. We're shipping this to client. But we want to bring the ease of use to the same level as the ease of use of our palletizing operation. All right. Here are the things that I want you to remember. The first thing is, well, palletizing projects are no longer complex projects, right? We've made them a commodity. And we've done this by actually tackling the ease of use and tackling the accessibility of those platforms as a whole. And, well, I'm well aware that there will still be a lot of custom solutions in the future. I don't think we're going to see the end of this, because just like laptops are great for a lot of people, there are still a lot of purpose-built computers to handle specific tasks. And that's why, as an industry, if we want to increase the adoption rate of automation, we need to focus on the adaptability and all the integration of those platforms. Ease of use is absolutely critical. The last thing is that, well, at BeRobox, we're using our experience to build the first palletizer and depalletizer, not with a new, shiny product. I'm talking about a platform that's already established, running day and night around the globe. My name is Charles, and I can't wait to have you to present the next iterations of this. Thank you.